Let's examine friction in the context of CubeSats. In the previous video, we made an inexpensive dynamics track and cart system. Usually track and cart systems that you buy have almost no friction. The one we made does have friction, we think. All is not lost, however. Friction is something that we can study and learn about. Since our track and cart system has friction, let's examine it. In the following experiments, we will use observation with our eyes and ears and the camera to find out about the friction in this track and cart system. Earlier, we wondered if there was something that was slowing the turning of the wheels. Friction can do that. Slower turning wheels will make the carts move slower down the track. We have two carts to try. One will be named Red Cart because it uses red rubber bands. Meet Red Cart. The other cart will be called Tan Cart because it uses tan rubber bands. Here's Tan Cart. Now observe the wheels of the red cart and tan cart as they go by and try to see if they are turning. Red cart. Red cart. Red cart. Slow motion. Red cart. Slow motion. Tan cart. Slow motion. Did using the camera and slow motion video help with your observations? Could you see the wheels turning? Could you see when the color of the rubber bands were red or tan? I put chalk marks on the wheels to help me see the turning. Did you see the marks? Did slow motion help? Let's observe again. Tan cart. Red cart. Tan cart. Slow motion. Red Descartes, slow motion. My observation was, with the help of the camera, I could see that the wheels were turning. There is not too much friction in the bearings in the wheel hub. The carts will roll down the sloped track. What did you observe? Let's raise the height of one end of the track. That will increase the slope of the track. Observe how the carts roll down the track now. Tan cart. Red cart. You could not tell much about the friction in the system with this higher slope of the track. However, tan cart appeared to roll slightly faster down the track than red cart. If that is true, then tan cart experienced less friction than red cart. The less friction a cart experiences at its ball bearings, the faster it rolls down the track. Tan cart. Red cart. Now, let's lower the slope of the track. We will set one end of the track lower so that it is even lower than it was, while at both of the other two heights. We now have the lowest slope of the day. Observe how the carts roll down the low sloped track. Tan cart. Red cart. motion video. It was real time. At the lower slope of the track, friction was very observable. Friction was what caused the carts to stop rolling near the middle of the track. Changing the slope of the track changes how gravity works to pull the carts down the track. Gravity is making the carts roll. Red cart. Did you observe that at this lowest slope, red cart went further down the track than tan cart? And the tapping on the table caused the carts to start rolling again down to the end of the track? Did you also see the shadows of objects moving in the wind? Usually, tan cart behaved like it has less friction than red cart, but not so at the lowest slope of the track. Also, what about the tapping? What is it doing to the carts and tracks to cause the carts to roll? What about the wind? It could be an external force, and we have already seen what external forces can do. Tan cart. It seems that an experimenter's work is never done. The importance of friction in the context of CubeSats. When CubeSats are put into orbit by a CubeSat launcher, friction can cause them to stop moving before the launch is complete. To prevent this from happening, materials must be used for CubeSat construction that prevents friction from stopping their launch. That material is not wood. It is anodized aluminum. An experimenter's work is not yet done. Subscribe.